recap, because now I want to have this like the full video for this. Just to recap for part A, h prime of 2, that's the slope at 2. If this is your slope of the tangent line, then we know that A is going to equal whatever the slope is, which is going to be 2/3. As far as B goes, let A be this function. So if we use product rule, so when I take the derivative of this, A prime of x is going to equal, what's that, 9x squared times h of x plus 3x cubed times h prime of x. And they're kind of sneaky here. They like, the AP exam loves to use previous answers in problems. So they want to know, what's a prime of 2. So it's going to be 9 times 2 squared times h of 2 plus 3 times 2 cubed times h prime of 2. Okay, 9 times 4 is 36. H of 2, they tell us h of 2 is 4. Plus, let's see, 8 times 3 is 24. And h prime of 2 we already found up here to be 2/3. And then you get your answer. So, as evil as part C and D are of this question, I don't think A and B are that bad. And in general, every free response question, if you look at part A is supposed to be easy. Which means if you're thinking about it really hard, you're probably not thinking about it the right way. Every part A should be easy, right? And typically, if you think it's hard, it has a lot to do with you overthinking it. Now, I want to talk, I really want to just give you an example of what they do in C and D. These are random, right? I've never seen a problem like this. The part D actually uses a squeeze theorem. I honestly haven't seen a squeeze theorem problem on a free response question, like ever, except this year. So whenever you typically question 6, sometimes it's 5, but usually it's 6, it's just a bunch of random stuff. But let's talk about C for just a second, right? So function h satisfies this, right? So h is equal to this mess that uses f of x. It is known that the limit as x approaches 2 can be evaluated using L'Hopital's rule, right? Using the limit as x approaches 2 of x, find f of 2 and f prime of 2, and show the work that leads to your answer, right? So to be very honest, I had issues finding this, right? So I will find that later. I want to talk about the part that I thought was easy to find. So the part that I thought was easy to find was, if they said L'Hopital's rule works, what does that mean?
You get indeterminate form, which means you get 0 of 0.
What?
You get 0 of 0.
You get 0 over 0, right? Does everybody see that? So if I get 0 over 0, that means that x squared minus 4, well, it's actually that when you do limit as x approaches 2, so when you plug in 2, you better get 0 over 0. And so when I plug in 2, well, do I get 0 on top?
Yeah, 4 minus 4.
Perfect. And so I need to make sure that, actually I lied. I had trouble finding this one. This is the one this was the easy one to find. So this says when I plug in 2 in the bottom, I better get 0.
Which means that.
Okay, so for part C, I do 1 minus f of 2 cubed better equal 0. Are we okay that f of 2 is going to equal 1 with this now?
Because it's cube root form.
Yeah. Are we okay with that? So that part I thought was pretty straightforward. How do you find that, right? Like, right, how do you find that? Okay, so I found out that f of 2 is 1. How do we do this? Well, I guess we should use L'Hopital's rule, shouldn't we? Because they said we use L'Hopital's rule. So and I'm going to write this just so I have board space. So I know that f of 2 is equal to 1, and I'm going to erase this. And I'm going to use L'Hopital's rule on this. And so L'Hopital's rule is going to be the limit as x approaches 2 equals, so derivative of the top is going to give me 2x, derivative of the bottom, well that goes away, that's going to give me minus 3 times f of x squared times f prime of x. Are we okay with that? So far, so good? And if I'm interested in limit as x approaches 2, that means, okay, I want to plug a 2 in here, and I'll plug a 2 in here. And plug a 2 in here, right? So far, so good? And so that's going to give me 4 over, well, f of 2 we already know is 1, so it's going to give us -3 times f prime of 2. And we're stuck, right? Right? So now here's the part that I had to look up. What is the limit as x approaches 2? This is mean.
As x approaches 2?
Yeah. What is limit asking? What is limit looking for? Limit is always looking for a y value.
Yeah.
Is everybody okay with that? Does that make sense? Every time you've computed a limit, you are looking for a y value. Sometimes this limit goes to x goes to infinity, you're looking for what y value you're getting close to, right? But anytime you're computing a limit, you are looking for a y value. What is the y value of h at x equals 2?
4.
4.
Oh, because it satisfies h.
Do y'all see that? That's what I had to look up.
That's not nice.
I told you it was me. And I'm going to wave my hands a little bit and say, okay, so this means f prime of 2 is going to equal -1 after you do some algebra. I don't know how many students got that. There's the average of this, and I can't remember what the average out of 9 this is, but I have a feeling a lot of people didn't get this part,
Yeah.
because that's just me. As far as part D goes, it says h is always bigger than g. Between 1 and 3, let k be a function satisfying that k is in the middle. I say, is k continuous at x equals 2? Justify your answer. So for something that, I do need to review this because this is something they do ask. Mathematically, how do you show something's continuous at a point?
So you prove the limit from the left, the limit to the right, and the limit at the...
The limit from the left equals the limit from the right equals the y value. Does everybody remember that? You need 3 things. You need the limit from the left, you need the limit from the right, and you need the actual y value. Right? You got to go here, and the dot has to exist. That's what it means to be continuous. So anytime they say is something continuous, you have to say, well, the limit from the left, limit from the right equals this. So first, so if h is always bigger than g, right? Let's see. Wait, what did they give us about g? Oh, they say that g and h are both twice differentiable, right? Translation, anytime I tell you something's twice differentiable, that means it's nice. All right? And also, if it means it's nice, that means it's continuous. So we know that g and h are continuous, and we know that g is always bigger than h. Now, what do they tell us about k?
It's between the two.
It's in the middle, right? And what can you tell me that's happening at x equals 2? Based on this,
They're the same.
they're the same. So if h is always bigger, so here's 2 and here's the point 4. If h is always bigger, it does this, right? We'll call this h. If g is always smaller, it does this, right?
But since k is between them, it also has to be exactly there.
Exactly has
so
to be.
So it be continuous.
So does everybody see that k has to be at that same spot? So here's what we know. It is known, k being satisfied by this, is k continuous at x equals 2? Well, first we can say that k of 2 is equal to 4, right? And that's by the squeeze theorem, that's that whole squeeze theorem thing. And then, to be honest, what you actually have to do to get the other points is you have to talk about the limit. You talk about the limit as x approaches 2 from the left of k is equal to 4, and the limit as x approaches 2 from the right of k of x is equal to 4. And you can say all that by the squeeze theorem. All right. I don't want to spend a whole lot of time on this because I would need to spend time on the first 2 questions from 2018. Um,